This is Mr. Hassan's Maths channel, and this is question number 3 from the October-November 2022 IGCSE Cambridge Paper 4 Variant 2. This question is about this frequency table, which is a grouped frequency table, and it is as a result of Kay and Anne carrying out a survey on the distance traveled in kilometers by 200 cars. Kai completes this frequency table for the data collected. So 7 of the cars traveled between 80 and 100 kilometers, 33 of them between 100 and 150 kilometers, and so on. So the frequency represents the number of cars who traveled between those distances. So we got to calculate an estimate of the mean. Now the first thing you got to understand here is what we're doing is we are estimating, because the reason why we are estimating is because we don't know how far any of these cars travel. These 7 cars, we don't know exactly the distance they traveled, but they travel somewhere between 80 and 100. Some of them could have traveled 81, some of them could have traveled 100, some of them could have traveled 75. We don't know. So we have to do an estimate of the mean by taking this interval and finding the mid-interval value, the halfway between them, which is found by adding them together and dividing by 2. So 180 plus 100 is 180, divided by 2 is 90. We can kind of see that it's kind of obvious. 90 is a mid-interval value. So that now becomes we call it the x value. 100 and 150, 125. 250 divided by 2. 150 and 200, 175. That's 350 divided by 2. 200 and 300, 250. 500 divided by 2. 300 and 400, of course, 350, or 700 divided by 2. So those are the mid-interval values. And to find an estimate of the mean, okay, what we're going to do is we're going to say, all right, so basically those 7 cars, we don't know how far they traveled, but we're going to make an estimate that they all traveled 90 kilometers. We're estimating that they all traveled 90 kilometers because we don't know how much they traveled, but somewhere between 80 and 90. So we just take, let's say all of them traveled exactly halfway between that. That's the best you can do because we don't have the actual data, so we have to estimate. So you do 7 times 90. So that's the total. Now remember the mean. What is the mean? The mean is the sum of all the values, okay, in a set of data divided by the number of entries. Okay, so we know we're going to have to divide by 200 because the sum of all the entries is 200, as they told us here. If we added these frequencies together, we're going to get 200. Because they told us that already over there, we don't actually need to add them together. If they didn't tell us there was 200 cars, if they didn't tell us there were 200 cars, then what we would have had to do is we would have had to add these frequencies together, and they would have given us 200. All right, now, so these 7 cars, we estimate that each of them traveled 90 kilometers. So that of the total sum of the distances that these traveled is 7 times 90. Now we've got to find the total sum of all the distances of all the cars. So we've got to do the same for each one of these categories. So we're going to add to that 33 times 125. And we've got to add to that 76 times 175. And we've got to add to that 52 times 250, and add to that 32 times 350. And all of that is to be divided by 200. Okay, and so that's going to give you your answer. So we can just, those are the steps that are essential for you to give, right? For you to get the marks for a question like this. So now we're just going to be very careful when we put these values into the calculator. Okay, because it's very easy to type something wrong and then you'll lose some marks. I mean, if you show your steps, that's of course very, very important that you'll get most of the marks, the method marks for this question like this. You'll get them for showing the mid-interval values correctly, for multiplying by the numbers correctly, for dividing by 200. There'll be a few method marks here, which you will get definitely if you show those steps. So now we're going to put the values in very carefully. So 7 times 90 plus 33 times 125 plus 76 times 175. See, 175. Be very careful. Okay. Just make sure that I type them all correctly. 7 times 90, 33 times 125, 76 times 175 plus 52 times 250 plus 32 times 350. Divided all of that by 200. And that gives us 8451 over 40, 8451 over 40, which, of course, we have to round it if it needs rounding. So we press SD. That gives us 211.275. 211.275. Now, an answer like this, they don't tell us how to round it. Because it's like an exact value, you could write this as 211.275 because it stops there. That's fine. Or if you wrote it as 211.3, that's also fine. Okay, because it's just an estimate anyway, right? So either of those are fine. If you write it like this because it stops there, that's fine. If you write it like this, it's also fine. No, sorry. What am I talking about? 3SF would be 211. Okay, if you write it like this or this, both of them would be fine. Okay, 3SF or to exactly as what your calculator shows because it stops. It's considered like an exact value. Both of those answers would be fine. So that's part A done. Now for part B, it says, and uses this frequency table for the same data. There is a different interval for the final group. So they're telling you what the difference is. Everything else is the same. All the numbers are the same, but the interval for the last group is different. It goes from 300 to 360. That goes to 300 to 400. So here the mid-interval value is going to be 330. And here the mid-interval value is going to be 350. Right? So without calculating an estimate of the mean for this data, find the difference between N and K's estimate of the mean. You have to show all your working. So what we can do here is we can basically, without actually calculating this, we have to find the estimate or the difference between the two estimates of the mean. Okay, that's what we have to do without actually working out the new mean. What they don't want you to do is calculate the new mean with these values and then show the difference between them, saying without calculating an estimate for the mean of this new data, find the difference between their two estimates. So if we were to think about this question here, then the only difference between these two, this and the mean for this, would be in the last part here. Everything else would be exactly the same. Everything would be exactly the same. So basically, if we consider this as a separate fraction, we could 32 times 350 over 300 over 200. 32 times 350 over 200, right? So we consider that as a separate part. So we have the initial value was 32 times 350. Okay, and we consider that over 200, which was the original amount. That's just the last part there. Okay, now, what will be the difference? The difference will be now, it's going to be 32 times 330 instead of 350. So the difference between those two values, the difference is going to be, okay, is that you're going to have, the difference between those is basically 32 times 20. The difference between these is basically, if you think about this, and that's over 200, so that's going to be 32 times 20, all right? Because you got 32 times, you can think of that as a common factor, 350 minus 330 over 200. So it's like 32 times 20 over 200, okay? Because that will be the difference between them. It's like you've taken this and you've separated it into, you can say, a separate fraction. So this is going to be over 200. Okay, so you've separated that as a separate fraction. And the mean, is going to be basically this plus the difference between these and those. This and that. Because the only difference is going to be, instead of 32 times 350, it's going to be 32 times 30, which is basically 32 times 20 less. Okay, so it's going to be less by this much. So that cancels with that. That gives you 10. So it's going to be 3.2 less kilometers. You can say minus 3.2 if you want kilometers. That will be the difference. You can mention just 3.2. In fact, you don't have to put more or less. Okay, as you wish. You can put 3.2. It says just the difference, 3.2. You can put minus 3.2. You can put 3.2 less. You can just write 3.2. The difference between them, and that's fine. Now, going back to this answer here, I'm thinking that I would just leave it like this. Okay, because it is an exact value, and the question, if you look at back at the beginning of the paper, it says here, instructions are, Give non-exact numerical answers correct to 3 significant figures. So that would be considered like an exact value. Okay, what we just looked at now. Where were we? We're at question number 3. So I think it's over here. No, that's 5. There's 3. Okay, that's part 2 of 3. Okay, yeah, so that would be considered an exact value. So I would leave it as 211.275. And here, the difference is 3.2. So you can write 3.2. You can write 3.2 less. You can write minus 3.2. All of those are perfectly fine. But I hope you understood what we did there. Basically, we took this part, the only part that's different, we took it like separately. Okay, and then we basically saw the difference between these two. This would be 30 times 350. This is 32 times 330. And that gives you basically 32 times 20. That's the difference between that answer and that answer. But we got to divide it by 200. Okay, because that's the denominator for that, and that's how much it's going to be, less than the original, the mean. Okay, so there's the answer to number 3A and 3A part 1 and 2. Okay, so again, the important thing for you to understand here is you don't calculate an estimate of this mean and subtract them. You can do that if you want to make sure your answer is correct. If you went and calculated the mean from this, without showing the steps here, but just in your calculator, and then, show that this is exactly 3.2 less than the value that we got before, then you can be kind of rest assured that you did the right thing. Okay, you can be sure that you did the right thing. So 7 times 100. So we'll have exactly the same. Up to there will be the same. In fact, we could even do that now, and just to confirm, because that's still going to be in our calculator somewhere. Yeah, so we can just go back to this. Okay, and we can actually calculate this as 32 times 330. So we can change that to a 330. Okay, and we can see that our mean is this much, and if I subtract from this 211.275, which was our exact value, it gives you minus 3.2. So you can confirm in your calculator that you did the right thing when we did this, and be assured, rest assured that we did do the right thing. It's not that difficult to do, but you don't actually calculate the mean. You don't do that to answer this question, because it says without calculating the mean. They want you to have that understanding of how to do it. So that's part 1 done. That's dealing with estimating the mean. Well, it's all, I guess, estimating the mean. And now part 2 is all about histograms. So a histogram is drawn showing the information in Chi's frequency table. So Chi's frequency table is, okay, it's the first one. Okay, this is Chi's frequency table. Okay, so I'm going to actually take this information here. Let me just move this out of the way for a second. 1 second, it's not going to move. Okay, so here's the frequency table from the last page. Okay, it says a histogram is drawn showing the information in Chi's frequency table. So that's the Chi's one, the one on the top. The height of the block for the intervals 200 to 300 is 2.6 centimeters. So we can say the height of the block for this one is 2.6 centimeters. That's the height. Calculate the height of the block for each of the other following ones. So I'm going to write this up here, actually, it's better. So we want to find the height of the block for each of the following intervals. Okay, 80 to 100, we want to find this. 150 to 200, so we need to find what's over here. 150 to 200 and 300 to 400. Okay, they don't want us to find that one. They want to find these three. Okay, so now what we should understand is in a histogram, the height of the bar is not determined by the frequency. Okay, the area of the bar is proportional to the frequency. The height of the bar is proportional to the frequency density. So we need to find what the frequency density is for these intervals that we need to, find. Okay, and we can do that by dividing the frequency by the interval. So this is 7 divided by 20. Okay, so this would be 7 divided by 20. So 7 divided by 20, which gives us 0.35. So that's the frequency density of this first one. We don't need this one because they didn't ask us to find that, so I'll leave that. And we've got 76 divided by This is 50. So 76 divided by 50. Okay, that gives us 1.52. And then we have 32 divided by 100, which is 0.32. Okay, so we need to find what these are. I'll label them with letters so that it's a bit clearer. So I'll call this X, Y, and Z. Okay, we also need to know the frequency density for this one. That's important because that's the one that we have the information about. So the frequency density for this one is 52, okay, divided by 100. So that's 0.52. Okay, so now, because we have all the information about this section here, I'm going to use this in order to find what the others are. So I'm going to basically cross multiply this with this. So I'm going to say X is equal to 2.6 times 0.35 over 0.52. That's going to be what X is because they're proportional. Okay, so 0.35 X, you could say X centimeters represents a frequency density of 0.35. And Y centimeters represents a frequency density of 1.52. 2.6 centimeters represents a frequency density of 0.52. Okay, because this is the heights of the bar, right? Those are the heights of the bar. So this height represents this frequency density. So they're proportional to each other. So X equals, so basically 0.35 represents X. Okay, so X represents 0.35. How much does 2.6 represent? Okay, so basically 2.6 centimeters represents 0.52. How many centimeters represents 0.35? So it's basically using proportion. Okay, so you can say X equals 0.35 times 2.6 over 0.52, and Y, similarly, for Y, it's going to be 1.52 times 2.6 divided by 0.52. And for Z, it's going to be the same. It's going to be 0.32 times 2.6 over 0.52. Okay, so all of them will have 2.6 divided by 0.52, and you multiply that by each of those lengths, basically. So if we do 2.6 divided by 0.52, okay, that's the ratio you have to multiply everything else by. Okay, 2.6 divided by 0.52 times 0.35. So this is 5 basically. So 5 times 0.35, that gives us 7 over 4, which is 1.75. So that's X. Okay, so that's 1.75 centimeters. And then we have, for the second one, we're going to have basically 1.52 times 5, which gives us 38 over 5, which is 7.6 centimeters. And then finally, we have the last one, which is going to be basically 0.32 times 5. So 0.32 times 5, which gives us 8 over 5, which is 1.6 centimeters. So those are the heights of the bars, okay, for these three sections, of these three bars of this histogram. Okay, now for part B, it says one car is picked at random. Find the probability that the car has traveled more than 300 kilometers. Okay, so now, let me just copy this so we can see it next to the questions. Okay, so I'll just put it up here so we can see it. So one car is picked at random. Find the probability that this car has traveled more than 300 kilometers. So more than 300, well, there's only 32 that are more than 300. Okay, out of our total of 200. So that's going to be 16 over 100, which is 8 over 50, which is 4 over 25. So 32 over 200. It's best to write yours in simple form, 4 over 25. So 4 over 25, you can write that as 0.16 if you want, multiply by 4 and 4, yes. But that's fine. Okay, 2 of the 200 cars are picked at random. 2 of them. Okay, find the probability that both cars have traveled 150 kilometers or less. Okay, so both cars, right? So you pick a car and then you pick another car. So you got to be careful here, right? So you pick one car, there's 40 cars altogether out of 200. That's the first pick. But the second pick, you've already picked one of the cars, and that car has traveled less than 150 kilometers because we find the probability that both of them does. So the second pick, there's only 39 cars and only 199 cars left, okay, in the whole group. So there's only 39 cars that have traveled less than 150 kilometers, okay, and there's only 199 cars left because you already picked one of them. Okay, so that will give us our answer, and we should write it, I guess, as a simplified, as a decimal if it doesn't come out as a fraction, which I doubt. 400 over 200 multiplied by 39. 39 over 199. That gives us 39 over 995. Okay, I'll leave it like that. 39 over 995. That's an exact answer there. Okay, so there's a part 1 done. 39 over 995. Then it says one car has traveled more than 200 kilometers and the other one, so let me again do this so I like to see the question right in front of I need right in front of the question. So one car has traveled more than 200 kilometers and the other car has traveled less. Okay. Okay, now, where's the question? I've covered it. Sorry. That's the question. Find the probability that two of the 200 cars are picked at random. Find the probability that one traveled more than 200 kilometers and the other one traveled 100 kilometers or less. Okay, so basically more than 200 kilometers would mean these two. So 52, okay, plus 32 over 200 times, and the other one has traveled 100 kilometers or less. So that's going to be 7, because there's still those 7 there, because we looked at those ones before, right? But there's only 199 cars left. That's going to give you 84 over 200 multiplied by 7 over 199. Let's see what that gives us. So you have 84 over 200 multiplied by 7 over 199. That gives us 147 over 9950. Over 9950. Okay, so there we have our answer for part 2 as well. Okay, let me write that a bit neater. 147 over 9950. Okay, 147 over 9950. So there's the answer to part 2 of question 3b, and that concludes this question. Okay, that concludes this question 3a and b. Other questions from this particular paper you'll find in the playlist that appears in this corner of the screen at the end of this video, and the playlist linked over here is going to be all about estimating averages from frequency tables. This is going to be all about histograms. Okay, this all about histograms. You can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.